When you discuss Windows on this Congress, the Windows operating system, it can be a very heated discussion. I don't know how many of you have tried that, but, well, most large software companies have improved their security to the positive, and that also applies to Microsoft with their Trustworthy Computing initiative, for instance. This talk, One Token to Rule Them All, is about how much fun you can have with access tokens on Windows systems once you're on there. And the presenter is Luke Jennings. Please give him a warm welcome.
Okay, hello CCC. Right, what's this talk going to be about? Well, this isn't something that's completely groundbreaking that no one has ever thought of before, and it's something that's come out of pen testing, which is what I do as my primary job. And it's something that I think has been overlooked in the past, and it's something I found will affect a lot of corporate environments quite heavily sometimes, because it's something that I've found security managers haven't been quite so aware of and haven't taken into account as much as they probably should be. And to kind of, give the background, it's really focused on the idea of post-exploitation and how, in my opinion, that's become a lot more important in recent years. And that's purely because software has been becoming a lot more secure. And so, as a pen tester, you need to make the most of every compromise you get. So, focusing that on Microsoft technology, it's pervasive, it's everywhere. We all know Microsoft are huge, and every business has some element of Microsoft technology. And particularly, Microsoft have improved their security a lot in recent years. I mean, obviously, very famously, they were very poor some years ago, but since their Trustworthy Computing initiative, things have got a lot better. And now, if someone's gone about the right kind of procedures of patch management and secure configuration on a Windows network, you shouldn't be looking at being able to compromise a large amount of systems. And consequently, post-exploitation is a lot more important. So, the potential for token abuse as post-exploitation. Now, post-exploitation has been addressed by various people to some extent. Metasploit's a great example. And they've kind of added options like passive X payloads for kind of browser exploits, getting around proxies, that kind of idea. The Meterpreter has been added, which kind of gives you a lot more powerful options once you've compromised the box than maybe a Windows command shell would. And it's a lot more flexible. But Windows access tokens has been less investigation publicly. And they are integral to Microsoft's whole concept of single sign-on in an Active Directory environment. So, I mean, we're talking about the case of you log onto a Windows desktop, and once you've logged on to that Windows desktop, if you're going to access a remote file share, you don't need to enter your credentials again. It's all transparent, and that's because of the way access tokens behave. And I found that on tests, it's often difficult to convince clients of the importance of keeping their administrators' desktops or other desktops and systems in general just as secure as their critical servers, because the security of the two systems are far more linked than people often give it credit for. So just to give a quick overview of Windows access tokens, what I kind of found was that when I was initially doing this research, is they're not quite so well understood among the security industry as the kind of common equivalent in Unix environments. So I mean, in Unix, the whole access control model is in your face from the very first day you use it. As soon as you do it, type a ls-l, you've got directory listings, and then you see the files, see the directory, see who they're owned by, and you see the access control permissions. And then people are aware of the whole idea of set UID to kind of drop privileges and so forth. Windows has a concept of a primary token which dictates its privileges. And so, by default, being a multi-threaded operating system, threads will use this token when they're actually executing. However, they can temporarily impersonate other tokens, and they can be taken from various different means, which I'll describe in a second. So, tokens have 4 different security levels primarily, and they're listed there, and you can see anonymous identification, impersonation, delegation. Now, we're mainly going to be concerned with delegation here and impersonation to some extent as well, because they are the security-sensitive ones. And the idea is that a delegation token will withhold your credentials such that it can access remote systems on your behalf. So, going back to the example of when you log in and access remote file share, there you're talking about delegation tokens because they actually have the necessary privileges to do that. An impersonation token, on the other hand, doesn't contain your credentials, so that's only valid on a local system. And that would be the case if you have, for example, an FTP server and there's a non-interactive login to it. If you connect to the FTP server, then that will create an impersonation token which the thread that's handling your request can then use from then on to deal with the request and make sure that everything that's performed is performed in the context of your user account. So really, it's the kind of divide is that interactive logins will normally create a delegation token, and non-interactive logins will normally create impersonation tokens. But they can occasionally produce delegation tokens if a service or a computer has been trusted for delegation. And a good example of that is if you use an EFS file server, it needs access to your credentials to decrypt your files. So if you access it remotely, it wouldn't be much good if it wasn't given a delegation token. It wouldn't be able to decrypt your files for you. Okay, so the way they can be abused can really be divided into two main areas. And that's one, the first and the main form is what I kind of term domain privilege escalation. And that's the case of, if you're really looking at delegation tokens here, if a domain user token is available, then you could potentially use it to access other systems. So if you compromise a system, and I've given the example there, particularly of a database administrator's workstation maybe, if you compromise that, then he's logged in with his sensitive administrative account, then you should be able to take his token and use that to actually access the database servers that he would administer. Whereas normally you might find they're very well secured, and it's a kind of different route in. Whereas with local privilege escalation, you're talking about under some limited circumstances, you might find that if you compromise a service that's an unprivileged service account, it's not local system, for example, you might actually be able to elevate your privileges. I know Dave Litchfield has spoken briefly about this before with regards to SQL Server. And the good example there is if you're following best practice and you install SQL Server and run it as a low-privileged account, then if someone compromises that and then an administrator connects that's, as you would expect, is a member of the local administrators group on the system, then once they've connected, there'll be an impersonation token created within the SQL Server process. So you can actually take that and then escalate your privileges to administrative on the system itself. So that's just one example. That's, with regard to these attacks, that's probably the less common case, and the more common case is the previous example. So, I mean, I mentioned before, okay, with the domain privilege escalation option, you could be thinking, well, maybe install a keylogger or something, something more traditional. And yeah, you could, and when I was initially pen testing, that was, one of the obvious thoughts, but on a pen test, you don't really want to start kind of installing too much software and rebooting systems. Ideally, it doesn't always please the client so much. And again, you're then reliant on someone actually retyping their password in. With tokens, it's all transparent. You can just take it. It requires no interaction. So based on these issues, I kind of went about writing a tool originally. And I thought, okay, well, I've got to have certain functionality enabled with this. What do I need to do on a pen test? And of course, the first option is thinking, I've compromised a system. What tokens are actually present? Are there any tokens I can do anything useful with? And so that's obviously the very first option then was to kind of look into that functionality and implement it within a tool such that you could enumerate that information. And then second to that, once you've determined what's available, the common things you're going to want to do is just maybe execute processes with these different tokens, or kind of perform some group or user management. Just common post-exploitation tasks that are going to be those sort of things you're looking to do on a pen test to prove a point to a client. Okay, so the tool I wrote is called Incognito, and the kind of basic functionality I first added was to list the available tokens and kind of filter that by the unique username that's present or by group. So you might be looking for a particular group that has privileges to do something on the network. There might be 100 different members, so there's that option as well to filter by group. And then, as I said before, the other common tasks, so creating processes with a specified token. The common example being there, maybe you want to create yourself a command shell. Snapping challenge response hashes. So, I mean, if you force connections to remote servers and you've got a sniffer there, you can get the credentials as they fly across the network. And then, of course, going through all the tokens more on a mass exploitation type approach. If you kind of go through every token on the system, if there's a lot of them, and just say, well, I'll try and add a user to this host with everyone, maybe I'll get lucky. Or I'll try and add my current user to this privileged group with all these tokens, maybe I'll get lucky. And additionally, to make the tool a lot more useful, it can be used remotely, so it will install itself as a service, communicate over named pipes, and then clean up after itself afterwards. And that's very similar to kind of pwdump, which I'm sure many of you are very familiar with. So how do you actually go about enumerating tokens? Well, the approach it uses is to use the NT-query system information API call. So these are APIs that are part of NTDLL. They're not documented by Microsoft as such. They're kind of low level, but they've been documented elsewhere, and they provide very useful functionality. So that first call really, and you can use it to enumerate all the handles on the system. And of course, there are handles for many different types of objects. So the next one is NT-query object. That can allow you to filter down this information and specifically say, look at the ones that are tokens and kind of exclude all the other handles to files and so forth. So, I mean, once you've got a kind of short list of these tokens, there are lots of other kind of standard API calls that can be used to actually query a lot of good information about them. And, I mean, get token information will give you, kind of what user accounts are associated and a wealth of other information, what kind of the security context of it is. And then you can use other standard calls like lookup account SID to, to find out or to map the SID to a username and so forth. And it's whatever you're interested in, really. There's a lot of calls that can, at that point, be used. So, I mean, that's just a screenshot. I'll be demoing this tool in a minute, but it's just a screenshot of it running on my laptop many months ago. And so you can just see it. Obviously, that's reporting the tokens that were present and dividing by delegation and impersonation. And as you can see, the Luke J user, that was the user I was currently logged on with, so that was a delegation token. The other NT authority group of user tokens, they obviously are the standard tokens that are present on any Windows system that are used for running services and so forth. So creating processes. If you create a process with create process, funnily enough, normally on a Windows system, that will actually only use the current primary token. It won't use whatever token a thread's currently impersonating. So if you want to do that, you actually have to specifically use create process as user. Otherwise, you'll find that you'll probably get confused and won't realize why your process is actually coming out at a different token to what you thought it would. And again, I mean, that's a very useful post-exploitation feature. And that's just being used remotely, bringing up a Windows command shell. And of course, some of the other functionality can be added. You can use that to force connections to remote servers, for snapping the challenge response hashes. And then again, there's the kind of network management set of API calls. They can be used for performing group management. And put it all together, and you've got something that can be quite useful once you've compromised the system. So, okay, let's move on to the demo. Okay, so for the purposes of this demo, I've got, basically, I'm running 2 VMware machines. So I have a Windows 2003 server that's running as a domain controller, and the domain's called company. And then I have a Windows 2000 server that's a domain member. So just for the purposes of this example, I'm going to assume that you've compromised the Windows 2000 server and you want to see what you can do. So I'm just going to assume that you've perhaps cracked the local administrator password, and so I can connect with that. So I mean, this is just the kind of options that the tool provides and the functionality. So if I'm going to copy across this command I have here to list the tokens. And what you see here, this IP address, that's the Windows 2000 server. So I'm connecting with the local administrator account, and then I'm giving it the list tokens command. The -u is just to specify to list by user account, whereas I said before you can list by the group as well. So it'll attempt to establish a connection. As you can see now, it's copying across the service, and it's listed the tokens that are present. Now, I haven't logged into this system yet, so at the moment, the only delegation token you can see is local system, which is not useful to us, really. Now, the fact you can see the local administrator account as an impersonation token there, that's literally just because I've used it to connect to and create the service. That's why it's present. And again, it's not useful because we've already have access to that. But if I just log into the system now as perhaps the domain administrator, and run this command again, okay, we can see that the actual domain administrator's delegation token is present there. So, I mean, with this in mind, then we could think, okay, we can do something useful with this. So, I, for example, might want to create myself a new command shell. So here, the first bit's similar to before, just connecting to the Windows 2000 machine, but then saying I want to execute a new process. The -c just means to communicate via the console rather than popping up a new process, and that's because I'm using this remotely. And so I'll specify, use the company, the domain administrator, and execute command.exe for me. So now you see I've got a command shell up, and if I want to, you see the Win2K3N, that's the domain controller. So if I did a now I've obviously got access to the domain controller, so you can see where that's useful. Okay, so, I mean, that's a process, but as I mentioned before, here I've just tried to add a new user to the domain controller, say, successfully added the user, and now I should be able to actually add that user to the domain admins group if I would like to. So here we'll be saying add the group user, and the user I've just created called hacked, add it to the domain admins. So that seems to be happy with that. I'll just show you here now. Wrong VM, sorry. Here we go. So you can see we've obviously created that user now, and it's part of the domain admins group. So from one compromise, you kind of compromise the domain in this example. Right. Okay, so that concludes that first demo. I'll move back onto the slides now. Right. So at this point, you're probably thinking, yeah, maybe that's quite sensitive, but I'm only exposed when I'm logged on. So, once I've logged off, my token's gone. It's been cleaned up in the log-off procedure. There's no kind of element of risk at that point. But what I stumbled across when I was researching this is that's not always the case, and there's some odd little bugs that I kind of found. And as I said before, obviously you would expect, and reasonably so, that the tokens would vanish upon log-off. You think that's got to be part of the standard log-off procedure. But I found that on kind of unpatched systems, and I'll come back to that in a second, it's not always the case. If you log off, and you'll find that your token is still reported as being available. But the difference is it will say it's an impersonation token, so you'll think, okay, maybe it's just a bit of an oddity, but it's not so big a deal because it's been changed to an impersonation token. No one can use that to access other resources. But you can. So I'm not quite sure why that is, but the change appeared to occur sometime between Windows 2003 Release Edition and Windows 2003 Service Pack 1. I couldn't find any information on the web about it, so I think it's something that was either noticed by Microsoft and fixed silently, or perhaps it was just the consequence of a non-security change, but I don't know the exact cause of it. But it's something that can really introduce a lot more risk, because for one, it's those unpatched systems that are more likely to be compromised, and then it's a case of, in most corporate environments, you'll have a lot of servers and systems that don't get rebooted for a long time, and it's only when you actually reboot that these tokens finally disappear properly. So if you've got these development systems that have been online for 3 months without ever being rebooted, and maybe once, a few months ago, someone logged on with a privileged account, then at that later date, the system gets compromised, you'll actually find that their tokens are still available, could still be used. So I'll just show that now briefly. If you just bear with me while I quickly log off out of the Windows 2000 server. Okay, so I was logged into the Windows 2000 server as the domain administrator. I've now logged off. So let's see if I can find our old command for listing the tokens present. And now you see that, yes, as I mentioned, the token's still listed, but as an impersonation token. However, if I was to try and add a user again, now I'll create a different user. You can say it's successfully added the user to the domain controller, even so. And if I want to let's try and find my old command for the... Okay, and so that's, again, created me a second domain administrator account, and at the moment I'm not even logged on to that Windows 2000 box, so obviously that can really expose you quite a lot without you realizing. Okay, so what's another case where you can get unintended exposure? Terminal services is a good example, and this is just more of a kind of usability thing, and it's terminal services has the option of allowing you to just close a window and then it keeps your session open. So that's great. You can connect to a system remotely, leave something running for a while, come back and see where it's got in some time. And some people do that. Some people just close the window instead of logging off properly because it's the easier option, a single click and it's gone, rather than go and click and log off and then okaying it and everything. But the point is, it means that you leave your tokens around because your session hasn't ended. So again, that's another case where you end up having a lot of tokens spread about the place without you necessarily realizing that you've exposed yourself that much. And I mean, the point to be made is really, from my experience pen testing in corporate environments, this does lead to a hell of a lot of exposure, and when I've kind of demonstrated it to sysadmins before, they've often been really surprised and quite shocked as to just how many accounts that are privileged seem to be logged into so many different hosts, and it really does make a big difference on your overall network security. Right, so Metasploit integration. Okay, as a pen tester, I'm a fan of the Metasploit project. It's helps me out a lot on tests. It's a great tool to have as part of any pen tester's toolkit. And one of the features of Metasploit that I actually briefly mentioned before is the Meterpreter, which is something that I don't think is given as much credit as it probably should be. When I often notice people using it, but using Metasploit, sorry, but I very rarely see people actually making good use of the Meterpreter itself. And for those of you that aren't aware, the Meterpreter is basically a kind of replacement for getting back a Windows command shell. Sometimes the Windows command shell is banned or not present, and additionally, even if you do get access to Windows command shell, it's not as powerful as you'd like it to be. It's not a Unix command shell. It doesn't have all the functionality you'd like when you're hacking something. Whereas Meterpreter was written to actually be a kind of thread that can be injected into a remote process and add functionality. So, and you can even extend that at runtime, so you can add new DLLs, which provide new modules and new extra post-exploitation options. So when I was writing Incognito, it occurred to me that, especially since the Meterpreter runs as a thread, it would be excellent to have this sort of functionality built into it, because you could actually take a new token, get the Meterpreter thread to impersonate it, and once you'd done that, you'd be able to use all of the Meterpreter's existing functionality under the context of a new token, and it'd be almost like getting a whole load of new functionality for free just from one kind of simple integration. So I kind of went about looking into how to do that, and additionally, it means other parts of Metasploit could be integrated with this functionality. So these days, there's a lot of kind of automated exploitation that's part of Metasploit, which can be quite useful at times. And the Meterpreter is all scriptable in Ruby, and so you could kind of use this functionality to get it to automatically run once you've compromised the box, and you can get a lot done in a short amount of time if you really would like to. So I'll just kind of briefly show that. So I have a Debian system here, which I've installed Metasploit on. So I've left the Windows 2000 server unpatched, so this is just the RPC-DCOM exploit. Yes, it's old, but it just serves as a good example in this case. So I've already targeted Metasploit at the Windows 2000 server, and I've set it to use a Meterpreter instead of a command shell. All right, so at this point, we've got a Meterpreter shell open, and I just extend this slightly. So, I mean, the Meterpreter has all these sorts of nice options available for doing things. And one of the things that was already built into it was a kind of who am I type feature. And that's actually implemented in more of a kind of Unix style sense, and it's called getUID. So the only modification I made to this was that it will actually report the domain that's associated with the token. Before it didn't do that, so it would the standard Metasploit action is just to say system here, because we're likely to be dealing with different domains, and if you see administrator pop up, you wouldn't be sure whether the token was the local administrator or the domain administrator or whatever. So I made that modification, and once you can do that, you can see what you're running as. Now, in this example, I've exploited a core Windows service, so as you'd expect, the interpreter is running in the context of the local system account. But I wrote an extension module where I implemented some of Incognito's functionality. So if I load that now, you should see that some of the commands I spoke about before, they're available there from within this thread now. Now, I won't go through all of them because, for the most part, they're re-implementing functionality that I've just shown you. However, the key one to note that's new, really, is the impersonate token option. And I'll just kind of show you that because that's what I was just discussing. Now, I'm going to re-log into that box so it pops up. Actually, no, it doesn't matter. You can see that the company administrator token is available there as an impersonation token, again, because I haven't logged back in again. However, if I look at impersonating a token, I can then specify that. Okay, I do need to log back into the host, and I do need to make a change to my code as well. Sorry, if you just bear with me quickly. All right, so now you can see, okay, I've logged back in, there's a delegation token present. And with a bit of luck, hopefully, I'll impersonate that token now. Okay, so it's saying it's successfully impersonated that user. So now if I run getUID again, you can see that that's the interpreter is working within that context. Now, all the other functionality that's available in the interpreter will function under that username, which is a very powerful feature, potentially. And if any time you want to go back, if at any time you need to go back to the original context, you can always call revert to self, which is implemented already within the interpreter. Call that, and then back to system. So you've got a lot more flexibility there with what you want to do when you're exploiting. Okay, so that concludes that demo. Right, so up until now, I've really dealt with a case of, you've compromised the system already. What can you do with that system? However, there's a kind of different way you might want to think about it sometimes when you're pen testing, and particularly, this is relevant because a lot of the time a pen test, especially on an internal network, will be very focused. So a company might be interested particularly in the security of their critical database servers. And so they've probably put quite a lot of effort into protecting them, you'd hope. And you might find that your conventional testing techniques don't bring up anything of a particularly high risk. You don't find a way of, of exploiting the box outside of maybe some minor information disclosure or something. But you know that there are lots of other people that have interactions with that server or those servers on the network, and you start thinking you'd be interested in trying to find where their tokens are. Now, short of completely just blitzing the network and compromising every possible system you can in a real noisy fashion, trying to locate systems that might have a token, it would be much nicer if you could really search for that a lot more easily without going to that amount of effort and noise. So I started thinking, well, how can I find out what tokens are present on the system without compromising it? And so I you know, I kind of thought, you know, if I was trying to get into a database server, I'd want to try and find where the database administrator's workstation is, for example. And yeah, there might be other ways of doing that. You might even just be able to find out by looking on the company's intranet or something. But I did have a look through the kind of the Windows 32 API and thought, you know, there must be something that can give me this sort of information. So I did actually come up with a bit of luck, and I just found an API call called Network Station User Enum. And that's supposed to list the users that are currently logged on to a computer. And what I found was very useful about that was that you don't need a privileged account to use it. A standard kind of low-priv domain user account is enough to actually call that. So it's reasonable to expect, you know, an attacker on an internal network would already have access to that anyway, and on a pen test, you'd normally have access to that. Or if you hadn't been given a standard account, you'd probably compromise one pretty easily. So with access to one of those, you can then sweep all the systems on the network, trying to figure out who's logged into which. And it's not 100% perfect, because I found, similar to the kind of the issue I described previously, the vulnerability, in fact, about how tokens aren't cleaned up properly, it will report everyone that's logged in since the system was last rebooted. So there is a potential for false positive. However, that's also useful in the sense that if you're dealing with a system that is one of these older systems where, despite the fact they've logged off, you still can use their token, then it's useful, because then you're actually finding these, you know, you've got a method of finding these tokens even when people aren't logged on. So it's a kind of double-edged sword in that sense. So I kind of wrote a separate little tool that deals with that functionality. And I'll just try and demo it to you now. A bit of luck this will work. So as you can see here, I should be connecting with this account, which, well, I guess you have to trust me, is a low privileged account. As you can see, it's come back telling me that the domain administrator is actually logged on to this IP, which is the Windows 2000 box. So with only a simple standard low privileged account, I can actually, you know, query these boxes. And though I've only just given it a specific IP there, I mean, the tool takes a file, so you can give it a whole massive list of IPs or server names and let it go through a network. And having run this on the internal test before, you'd be surprised just how many systems you can, well, sorry, how many accounts you'll find logged into how many different systems. I was even surprised, and system admins I've spoken to about it were certainly more surprised than I was. And particularly good examples when you come across kind of Citrix systems where there could be, you know, tens or even maybe 100 people using one system, and you'll see straight away a whole massive list of these tokens, and it becomes a kind of critical point of failure. All right, so again, coming back to me being a penetration tester, once I'd kind of settled on this, on these tools and these techniques, I just kind of thought of myself, right, what's the basic methodology I need to apply for its use? And really, it's quite simple. It's just a case of if you're conducting a targeted attack, you know, decide on your targets, conduct your normal conventional penetration testing. You know, if you get in then, brilliant, job well done. But if you don't, then you know, you can then start employing these techniques to start sweeping a network. You know, ideally, the first stage of penetration testing might have revealed some information at least, such as who's a member of the local administrators group. And you'll think, okay, so now I've got these particular groups or these particular user accounts to start looking for. And then you can start sweeping across the network and saying, where are they? Once you've found those systems, hopefully you'll have a short list of new systems to attack. You know, and then you can look for weaknesses in them. If you find a weakness in one of them, then great. You can take the token, you can compromise the original target, and job well done, whereas without these tools you might never have really got anywhere and given a client the false impression that they might be quite secure. So yeah, that's really the basic technique. So, on to defense. Now, defense is a difficult one because this is a design feature. This is the whole concept of single sign-on that Microsoft kind of adopted with Active Directory, and there is no magic patch you can install that's going to protect you from these issues. However, there are things you can do, some of which are just general security best practice. So if you're already following some of these techniques, then you will have hopefully reduced your exposure to some extent. So, I mean, a good first example is limiting the use of privileged accounts. So use run as. Don't log into your desktop as your DBA account. Yeah, have your database administrators have a separate user account that's low privilege they use for logging in normally, and then have them run Query Analyzer or whatever tool they need to separately with run as with their admin account. And what's interesting to note is not only does that reduce the exposure as you'd expect normally, but even on unpatched systems, the ones that I mentioned before where a token would be left hanging around, if you create a process using run as instead, when you close that process, the token is legitimately gone. So even though if you'd actually logged in normally, then it would kick around even after you'd logged off for until the system had rebooted. So you get a much better level of protection even on those unpatched systems. Another option is an Active Directory option. Now this is limited in what it can do, but under some circumstances it can help you out, and that's the account is sensitive and cannot be delegated option. So the idea behind that is, you think, what are my critical accounts, and let's try and stop this functionality from occurring. Unfortunately, this doesn't apply to interactive logins. But when I mentioned before about how non-interactive logins can sometimes result in delegation tokens, which is where you've kind of configured a system to be trusted for delegation, under those circumstances, you can use this to help prevent really sensitive accounts from being compromised through this route. So that's something you should consider enabling for your kind of highly privileged accounts, if possible. But one of the biggest pieces of advice is just simply don't rely on securing only your most critical servers. You really have to think about the security of your enterprise as a whole. The desktops need to be secure in particular, the test systems, I mean, it's not just enough to say that, oh, my test systems and development systems don't house any real data, it's all dummy data, so we're not so concerned if they're compromised, because if the same people are accessing those systems, the same tokens are becoming present, and you can get compromised that way as well. And it's really, a lot of it's just changing your thinking, changing the way you approach things. Normally, people will often think about things on a kind of system level or on an account level. So on an account level, they say, well, this is a privileged account, this is pretty sensitive, so we've protected it because we've given it a strong password. So that's quite well protected, or maybe it's two-factor authentication. And this system, this is critical, and we've well secured this because we've applied all the most recent patches, we've given it a kind of hardened build, configured it securely. We've got lots of login enabled, whatever whatever approaches you've taken. But the two are far more interconnected, so you've really got to start thinking about, which accounts access which systems, and the issue is making sure that the weakest link along that chain of a particularly privileged account logged into a kind of slightly less protected box, that's the security of all those systems and all those accounts there and then. And the more systems you log onto, the more you spread that risk, and you kind of create a web of insecurity potentially. So you really have to change your thinking, and that's probably the most difficult part about this, because it's procedural, it's not a magic patch. And finally, probably one more issue is to make sure you use separate administrative accounts for accessing test and development systems. So I mean, again, that's fairly standard security advice and has been for years, but if you do it, then hopefully when those kind of weaker systems get compromised, even if someone does take the tokens that they found, they're not going to be able to use them for accessing much else other than that. Okay, so that pretty much concludes my talk. I hope it's been informative. If anyone's got any questions, they're welcome to ask them now, and if not, you can come and speak to me afterwards.
Will the source code for Incognito be free?
It's actually, I forgot to mention this, it's already present on SourceForge, so if you search for Incognito,
okay.
It's been present for months. I just haven't really publicized it very much.
Great.
So yeah, I'm not releasing anything new here, it's been available.
So does it actually work only with a Windows server, or does it only work with a Linux server as well, so if you're running Samba as a domain controller?
I haven't looked into Linux, but I wouldn't imagine it would. But I've focused the work entirely at Windows, so...
So you don't know if Samba is using those tokens as well?
The tool certainly wouldn't work, because it all relies on calling Windows API calls completely, and interacting with it in that way. But I'd have to look into whether how Samba actually stores things, because it's going to be different to the Windows kernel. But yeah, I mean, I wouldn't be 100% sure on everything without looking into it. So.
Okay, thank you.
I have a question about what are these tokens anyway. For example, can I steal it, keep it, and reuse it later on my machine or something?
It will only be in existence on the server that you've compromised. So really be looking at trying to go for more conventional techniques of persisting your access once you've got access to it. For example, I gave the example of adding yourself a new user. But yeah, the token's only present on that system, but it's just a housing for the credentials that are associated with it, like the NTLM hashes and that. So potentially you could just extract the hashes out of it and use them again, but the tool in itself doesn't provide the functionality to do that. Okay, thank you.